dy dx if y equals the natural log of the square root of x squared plus 2 over x minus 5, right? The first thing that we want to do is just simplify this function as much as we can before we try to take the derivative using our logarithmic properties. The first thing that I'm going to do, since there's division, is subtract them, separate them with subtraction, so I get y equals ln of the square root of x squared plus 2 minus the natural log of x minus 5. The next thing that I'm going to do, since we have a square root, that would be like x squared plus 2 to the 1/2 power. And then we are allowed to pull our power out front. So now I have y equals 1/2 the natural log of x squared plus 2 minus the natural log of x minus 5. Notice I have not taken the derivative yet, but now I'm ready to take the derivative. Please remember the derivative of ln u is going to be du over u. So that's what I'm going to be doing in this first case. X squared plus 2 will be my u, and in the second case, x minus 5 will be my u. So y prime equals 1/2 is a constant, so it's just going to tag along for the ride. The derivative of ln x squared plus 2 is going to be du, so the derivative of x squared plus 2 is 2x over u, which is x squared plus 2, minus, again, du over u, the derivative of u, the derivative of x minus 5 is 1 over u. Okay, and now I'm just going to clean it up a little bit. These 2's will cancel out. So we'll get y prime is equal to x over x squared plus 2 minus 1 over x minus 5. And I am good with that answer right there. If you wanted to get a common denominator, go for it. Right, number 2, find f prime of x. F of x is equal to the natural log of the absolute value of secant x. Please remember on this one, absolute values do not make any difference, so we're still going to have du over u. So in this case, my u is going to be the secant x. So when I'm taking the derivative, we'll get the derivative of u. The derivative of secant x is secant x tangent x divided by u, and our u is secant x. And then I notice that we can cancel our secant x's. So in this case, f prime of x will equal tangent x, and that is it on that one. Okay, number 3, differentiate, which means take the derivative. Y equals x squared times the natural log of x squared plus 2. Please notice that I said the word times, which means we must use the product rule. So we're going to let x squared be my f, and we will let ln of x squared plus 2 be my g. So f prime will equal 2x, and then g prime, this is a natural log, which means my derivative is going to again be du over u. My u will be the x squared plus 2. So the derivative of x squared plus 2 is 2x over the u, which is x squared plus 2. Okay, so I have my f prime and my g prime. I'm all set to do the product rule. So f prime times g, 2x times the natural log of x squared plus 2, plus f times g prime. So x squared times 2x over x squared plus 2. Okay, and then I could clean this up a little bit. I do notice that both parts have a 2x that I could divide out, so that is what I'm going to do to clean it up. So if I factor out a 2x, my first term will have ln x squared plus 2 left, and my second term, since the 2x will be gone, I will be left with x squared over x squared plus 2. And no need to get a common denominator or anything. That would be it. Okay, number 4, differentiate, which again means take the derivative. Y equals 3x squared plus log base 5 of 3x plus 4. Since there's a plus sign here this time, we can just take the derivative of each part separately. So I'm going to have y prime equals the derivative of 3x squared is 6x plus, this is a log. We know the derivative of a logarithm is going to be du over u, but what we will add is the natural log of the base. So this one, our u will be the 3x plus 4. So du will be 3 over u, which is 3x plus 4, times the natural log of a, and our base is 5. And that is my answer. I think what I could do if I would like to clean it up a little bit, I noticed that we could factor out a 3. So if I did that, I'd get 2x plus 1 over 3x plus 4, natural log of 5.